in this video, we're going to talk about matter and particle theory. Okay, and first of all, we're going to go through states of matter. So how many different forms of water do you know of? So have a think of how many you know. First of all, you might know of water as a liquid. You might know of water as ice. Okay, and you might know of water as steam. Okay, so if you look at this, which is present at room temperature? So this one's present at room temperature. What temperature does this have to go to here? Well, this has to go to 100 degrees to get steam. You get water evaporating at any temperature. That's a physics thing. It evaporates at any temperature, but you only get steam once you get up to that kind of like all concentrated steam anyway when you get up to 100. Okay, ice is solid and the freezing point is 0. So the boiling point is 100, the freezing point is 0. Okay, and the freezing point is the same as the melting point. We'll talk about that later, but if something freezes at 0, it melts at 0. So if it gets higher in temperature, than 0, it melts, and if it gets lower than 0, it freezes. Okay, so how is steam produced? We've talked about 100 degrees, okay, and we talked about ice. So what form do metals take at room temperature? Let's go through some examples here. Copper, nice and solid, okay, and then you've got steel at room temperature, again nice and solid, but we have the one that doesn't fit with everything else, which is mercury, okay, which is the only liquid metal. Okay, so that's 3 examples of state of matter. So let's have a look at the oxygen. So oxygen is a gas at room temperature. Okay, it can be cooled to minus 2,219 degrees Celsius and be a solid. Okay, and it can be a liquid, which is when it's put into shuttles to use as fuel. Okay, so if we look at that and we look at this, okay, we know at minus 219 it's a solid. So as soon as we go above minus 219, so we get warmer, okay, it's going to go from solid to a liquid. See, this is not as low a temperature as minus 219. This is a slightly higher temperature, so it's going to be a liquid. And then room temperature, 25 degrees Celsius, even higher, so it's going to be a gas. Right, okay, so observation indicate that there are 3 main states of matter. There are not, there are more. But for your stage, there are. So 3 main states of matter: solid, liquid, and gas. Okay, and at different temperatures, different materials can occur in all of these states, and they change from one to the rest. So you'll be used to this kind of diagram, and this kind of diagram tells you all the things about the solid, liquid, and the gas. So, for example, they're close together in the solid, and they're close together in the liquid, they're far apart in the gas. If you're drawing it, you must draw the solids in rows. Now, I've got a lot of rows here, but you only have to draw 6 particles of a solid to get the marks. And they've got to be all touching, and they've got to be in rows, okay? Now, they vibrate on the spot, so they do this, right, on the spot, okay? And they're in a very regular pattern. Now, when it comes to liquids, they are randomly arranged. Now, to get the mark, you have at least 50% of them touching. At least. Doesn't mean you can't have 100% of them touching. Just have to have at least 50% of them touching. The more the better, really. Okay, and you can see they're very random, and they're kind of touching each other, all that kind of stuff. They move around each other and flow, okay, and you get that random arrangement. Now here, with the gas, random arrangement, much far apart, move quickly in all directions, and none of them are touching. Okay, right, we go for this one. States of matter. So if you look here, they have a fixed shape and they cannot flow solids, so they can't flow. They can't be compressed or squashed, and you should do experiments in the lab to show you that. And the particles are close together and have no space to move into. Okay, that's why they don't compress. Particles are not moved from place to place. Okay, you can't make a solid flow. Whereas a liquid can flow and they can take the shape of the container, but they can't really be compressed. Okay, and that's why they can be used in hydraulics. So if you hydraulics is where you have liquid in a tube and you push one end and then the other end is connected to something else and it will push the other end because the liquid in the center does not compress, it just gets moved. Now, particles are free to move around each other and they're very close together, don't have a lot of space to move into, which is why they can't be compressed. Right, anyway, this is your summary. Let's go on to the last bit, which is gases. They completely fill the container, they can't be compressed or squashed, and the particles can move quickly in all directions, and they're far apart. Okay, so that's your summary of your solids, liquids, and gases and how to draw them. let's talk about changes of state. So you need to know this diagram, okay? So this diagram, you need to be able to label all this. So why don't you stop the video and try and label all of these. So let's start off with one of our words, solidifying, okay? So solidifying, a liquid to a solid will solidify. Okay, now, if that's the case, there is another word for that you can think of as well. Okay, and I'll leave that to you. I'll come back to it in a second. Now, if we go to evaporation, okay, evaporation is where you go your liquid to your gas. So, for example, if I breathe out now, and I'll do it on here, I don't know whether you can see. Okay, so that's basically me breathing on here, and I condense. I'll do it again. Can't really see it, but trust me, it's there. Okay, now that means basically there is evaporated liquid in my breath that I am breathing onto there. Okay, so an evaporation happens at any temperature. Any temperature. You can get evaporation happening in the Arctic and the minus temperatures. Liquid is always changing to gas, but in very small amounts. Now, next one, boiling. Where does that go? Boiling, where does it go? Where does it go? Where does it go? Okay, here it is, right. That is also a liquid to a gas. But evaporation happens at any temperature. Boiling only happens at the boiling point. So the boiling point of water is 100, and so boiling happens at 100. Evaporation happens at any temperature. Condensing. Where's that? It's there. So basically the gas is going to a liquid, and that's condensing. Let's go to the next one, melting. Where's that? Okay, melting is when you go solid to a liquid. Sublimation, something people often get wrong. Okay, don't know. Where is it? Ooh, sublimation is solid to a gas. It misses out the liquid part, just goes straight. And iodine is really good at that. You get a chance to look at that. Freezing. That's the other word for liquid to solid, okay? And then it's called both the same in both directions, okay? So there is your big diagram, okay, which you might want to take down in your notes, okay? And that is how you do change of state. So we're going to talk about how to predict a change of state. So first of all, the given temperature, if it's less than the melting point, it's going to be a solid. So if I say the temperature, for example, is -2, water is going to be a solid because the melting point of water is 0. Okay. Given temperature is between the melting and boiling points. So the melting point of water is 0 and the boiling point is 100. So anywhere between there, it's going to be a liquid. Given temperature is greater than the boiling point, above 100, it's going to be a gas. Okay, so let's show you what this looks like in terms of a graph. So if you look at this in terms of a graph, you see the temperature going up here, and you can see that the temperature is going up over time, and then it goes flat. Now that is because, and you'll do this more when you go into physics in year 10, okay, this is because all the energy that's being absorbed at this point is breaking all the bonds between the atoms or the molecules, okay, so it's breaking it, so it's not being used to heat the thing up. So when all the bonds are broken and we got to the end bit here, and we're still putting energy in, then the heat keeps on going up, the temperature keeps on going up. But here we're breaking all the bonds between the particles. And then we get to the point, whatever bonds are left are broken here, and then the temperature keeps on going up. And this is our melting, so if you ever see a graph like this, you see the flat bit, that's your melting, followed by your boiling. Okay, let's look at the other way around. And this time you've got condensing. Again, this is when the bonds are reforming. And then the temperature keeps going down because you're freezing it. And this is where the bonds are reforming again. Okay, and that is our change of state graphs. Now, the last thing we're going to talk about is what's happening in these change of states and basically just giving you some ideas to go into questions if you ever ask them. Remember, the solid heats up, gains energy, okay? Vibrates faster. That type of energy you might know is kinetic energy, okay? So when it's moving, it's kinetic energy. It supplies enough energy to break the bonds. With enough energy, they move freely. We then go to the liquid. It heats up, it gains energy again, Particles move in random directions, faster, rolling over each other. Again, it breaks any remaining attraction. Okay, and with the temperature, gases just keep on expanding, going further and further and further away. Now, this is your video on change of state. I hope it was helpful again. Again, like, share, and subscribe, all that jazz. Okay, and I really hope it was helpful. Good luck.